let's go ahead and jump into this one. They've already given us f of x's domain. This is artificially restricted. We know that if there were no restriction, this would be all real numbers because a quadratic has no limit to its domain, no restrictions. To this function, the square root function, we want 6x minus 3 to be greater than or equal to 0. So that means we want 6x to be greater than or equal to 3, which means x is greater than or equal to 1/2. So the domain here is 1/2 to infinity. Okay, too easy. All right, so now we jump into, let's just remind ourselves, this would be 1 to infinity. Let's jump right in. So the domain of G. Domain of G is what we know, 1/2 to infinity. We're going to overlap with G, which is square root of 6x minus 3 in the domain of f. So what is the domain of f? No. It's been restricted artificially. Greater than 1. Greater than 1. So I'm going to square both sides. 6x minus 3. If I square that, I get 6x minus 3. It just drops that. And on the other side, 1 squared is 1. So as I solve, it looks like I get 6x is greater than 4. So x is greater than 2/3. So I see that I'm going to overlap these two intervals from 1/2 to infinity and 2/3 to infinity. Is there going to be a hole in this domain? I'm overlapping these two. Will there be a hole in this? Will there be a gap? No. What's the more restrictive of the two domains? Yeah, 2/3 to infinity. So if I were to overlap these on a number line, right, I'd have from 1/2 to infinity. I'm going to do this one in red. And from 2/3, well, 2/3 is more than 1/2. So if I overlap those, my answer, domain of, is this f of g? Yeah. F of g of x is 2/3 to infinity. Awesome. Okay, let's go the other way around. Let's do f of g, g of f. So the domain of f is greater than 1. I'm going to overlap that with f, which is x squared plus 1 in the domain of g. Greater than or equal to 1/2. This is going to be kind of nasty, but we'll make it work. So I subtract 1, what do I get? Negative 1/2. What will happen if I try to take the square root here? I'll get an imaginary. Now, if you think of this as a graph itself, right? X squared looks like this. That was a pretty decent sketch. Negative 1/2 takes place down here. This graph is always greater than negative 1/2, right? Therefore, the domain of this side will be all reals. X squared is always greater than or equal to negative 1/2. Therefore, when I overlap these two, if I overlap 1 to infinity and all real numbers, the least restrictive of them takes over. So the domain of g of f of x equals 1 to infinity. Pause down here.